In today's lesson, we are going to be looking at measurement concepts. So this is going to be a little bit of review, hopefully. We're just going to be kind of going over some perimeter and area and volume and surface area questions, just with some general shapes, just to get used to doing these calculations before we start looking at other concepts in terms of measurement. So first, just to distinguish between perimeter and area. So perimeter is the distance around a 2D object, and for area is the amount of space a 2D object takes up. And for area, we want to keep in mind that the units are squared, such as centimeters squared, millimeters squared, feet squared. So for example, we can see that if we were to imagine kind of a fenced-in area, the perimeter would be the fence going around, and the area would be the flat surface that is enclosed by that fence. So that's just kind of what we're looking at first, because we want to determine the perimeter and area for the following figures. So nothing too tricky. We have a rectangle here. We want to find the perimeter and the area. Now, if you don't remember the formulas for some of these shapes, I mean, some of the basic ones you should remember, right? We should remember for a rectangle, the area is equal to length times width, and the perimeter, actually, let me just switch these around, keep it consistent. And the perimeter, you could add up all the sides, or because it's a rectangle, we have a different formula. We could use 2 times the length plus the width. Let me use a cursive L just to kind of differentiate it between 1. Right, so those are the 2 formulas that we're going to be using. If you don't remember these formulas, that's okay. Again, like I said, these ones you probably should remember. But if not, you will get a formula sheet that has all of these formulas. Now, in some cases, they do have kind of multiple versions. Right? We see for perimeter, we have perimeter equals the length plus the width plus the width, basically saying that for this rectangle, we're adding up all the sides. This is our simplified version, or the simplified version of the perimeter. Same with here. So they sometimes represent them in different ways. They can also show them in maybe different versions, like here for the circle, whether we're given the diameter, d, or we're given the radius, 2 different formulas. And then for some of the area formulas, when we are either dividing by 2 or multiplying by 1/2, it means the same thing, right? If I multiply something by 1/2 or divide by 2, it means the same thing. So there's different ways that we could represent it. So again, how you choose to, or which formula you choose is up to you. Just keep in mind that they're all kind of the same. So I'm going to stick with these ones. We want to first determine what our length and what our width are for our rectangle. Now, it doesn't really matter which is which in this case, because I could just take this rectangle and say rotate it so it's standing up like this, and this would be 5 and this would be 15. So if I were to call this the length and this the width, then if I switch it or rotate it, this would be the length and this would be the width. Right? So either way, it doesn't really matter what you want to label as each. Right? So I'm going to say the length is equal to 5, or we'll say 15, and the width is equal to 5. Again, you could switch that around. It's not going to change your answer. Now, keep in mind, even though we don't see anything for these 2 sides, right, because it's a rectangle, the opposite sides are equal. So sometimes you might see these 2 lines, or you might see 1 line. Right? This is indicating that the side that has the same notation is going to be equal. So that means that over here, this will be 5 centimeters because it has 1 line. It matches this side over here that has 1 line. And then the top side is going to be 15 centimeters. Again, the double line matches the double lines here. So just for making the image a little bit neater, less cluttered, if the sides are similar, it may not show that. It would show something with the lines, or maybe it doesn't show anything at all because of the assumption that it is a rectangle, so we know what the opposite sides should be. So don't just assume that because there's no length or no measurement that there isn't a measurement for that side. So plugging these values into our formula for perimeter, right? So similar to what like we did with equations, I'm just going to plug in a value for each variable. So instead of L, it's going to be 15. And instead of W, it's going to be 5. So P, or the perimeter, is equal to 2 times 15 plus 5. Remember your bed mass, we have to do our brackets first. 2 times 20 is our next step, and we get 40 centimeters. Just making sure that we have our units. Area is length times width, or LW, right? We don't really show the multiplication sign in between. We assume that there's multiplication. We're going to replace the values with, or the variables with a value. So 15 times 5. I get area is equal to 75 centimeters squared. Right? So just making sure we have our units to differentiate between area and perimeter, making sure we have the correct units. B is a circle. Right? So again, circle, we have some dimensions. We have one dimension here. This is our radius, or R. So our R value is 10. Right? The radius, remember, is from the center to the edge of a circle. The other value that you might get might be the diameter, which is going from one side of the circle straight through the center to the other. And the diameter, how it's related to the radius, is that the diameter is equal to 2 times the radius. Now in this case, we don't really need that information, but that's just some side information that you might use later on depending on the question. But we have the radius of 10, so we don't need to worry about diameter. Now the formula, we need the area, and we need the perimeter. Now the perimeter of a circle is actually called something else. It has its own unique name, circumference, which is C. So C, circumference, which just means the perimeter. So C, the circumference, or the perimeter, right? And if we don't remember the formula, we can go to our formula sheet and we can see down at the bottom, we have 2. C equals pi times D, or C equals 2 pi R. Zoom in there. Okay. So we're given the radius, so we're going to use the one that's 2 pi R. So C equals 2 pi R. Actually, I'm just going to jump back to my formula sheet. I'll get the area formula as well, which is pi R squared. So I have my two formulas, right? One thing to note, right? Pi, the symbol, right? Not the food. Pi equals 3.14. Now there's lots of repeating decimals, or it's a repeating decimal. We've talked about that in the beginning of the unit. It's one of those irrational numbers. But pi is equal to 3.14, so you can round to 3.14 if you'd like. Your calculator should have a pi button as well. You might get a slightly different number because we've technically rounded pi, whereas your calculator is going to use as many decimals as it can of pi. So C equals 2 times pi times R, which is 10. This just becomes one calculation in your calculator, 3 numbers being multiplied, and we get 62.8 centimeters. For area, pi R squared, again, pi is just a number. Our radius is 10, and we're squaring it. So making sure that we follow BEDMAS, we have to do our exponents first. So I'd have to do pi times 100, because that is 10 squared, or 10 times 10. And I get A is equal to 314.2 centimeters squared. So again, making sure that we have our units there. Last one, we have a triangle. So a triangle, again, we want the perimeter. This one's going to be tricky. We're going to hold off on perimeter for this one just because we don't have quite enough information to actually go through and find the perimeter, right? Because we would need to have this side and this side. So we don't really have enough information right now to go through and solve it. So I'm just going to put a little note for perimeter. can't solve with given information. So we did learn, or we will learn, how to maybe solve these types of questions if we're given a little bit more information in terms of determining other side lengths. But for right now, we can't solve the perimeter based on what we're given. For our area, however, though, we can solve that because our area formula is base times height divided by 2. And we do have a base. That is the bottom of our triangle. So our base is 15, and the height of our triangle is 7. So I do have enough information for the area. So area is going to equal 15 times 7 divided by 2. Following bed mass, I have to do my multiplication first. So 15 times 7 is, I'm trying to do this in my head, or I'm just going to grab a calculator, is 105 divided by 2, and I get 52.5 centimeters squared. And so our area is 52.5 centimeters squared. Our perimeter, we can't determine that right now based on with the given information, so we're just going to leave that blank. Example 2. Now we're going to start to look at determining the surface area and volume for each of the following figures. Right, so surface area and volume are similar to perimeter and area, so to speak, but instead of 2-dimensional shapes, we're now looking at 3-dimensional shapes. So surface area would be, imagine we unfold our 3-dimensional shape. Imagine it's a box and we unfold it and lay it flat. The amount of area it takes up is our surface area. Or you could think of it as adding up the area of each face or each surface of our 3-dimensional object. The volume is the amount of space that a 3-dimensional object occupies. Right? So the amount of space it can hold, the amount of space it takes up. So similar to kind of perimeter and area in some ways. Definitely there's area, and then volume is kind of like the area of a 3D shape, so to speak. So we do have specific formulas for these shapes. Again, it's on our formula sheet. So if we go to the next page, or the back side of it, we have the surface area and volume formulas. Now with these ones, what you're going to want to be careful of is for the surface area and the volume, they tend to have the general formulas first, or kind of how the formula is being determined first, and then the actual formula at the end. So for example, let's scroll down to our rectangular base prism. So we don't really see anything here. We just have our formula. A equals 2 times width times height plus length times width plus length times height. For our volume, we can see it as telling us, well, the volume is the area of the base times the height. And then it tells us specifically what side lengths we're adding or multiplying together. Length times width times height. So the area base times height is just in general what we're doing. The bottom formula is exactly what we're doing. So when you're looking at these formulas, just keep that in mind. Use the formulas, kind of the bottommost formula for each section. So for the surface area, it was 2 times, and then in brackets, the width times the height, plus the length times the width, plus the length times the height. The volume was equal to length times width times height. Again, similar to when we looked at the rectangle, what we label the length, the width, and the height doesn't really matter, because if I rotate my box or change its orientation, these values could become the width or the height depending on how I think of it. So I'm just going to go through and say the length is 18, the width is 6, and the height is 9. For the rectangular prism, you could switch them around and it's not going to give you a different answer. So we're going to plug those values in. So width is 6. So 6, I'm going to use square brackets here because I'm going to have a bunch of brackets on the inside. we're going to have 6 times height, which is 9, plus 18, times 6 plus 18 times 9, and close that square bracket. Let me just move this over. I'm going to go through and simplify. I need to do what's inside my brackets first. So 6 times 9 is 54, plus 18 times 6, which is 108, plus 18 times 9, which is 162. Now I'm going to add all of those up. So 2 times 324, and I get 648 centimeters. And because it's an area, I'm squaring it, 648 centimeters squared. Volume's a little bit easier. Volume is just length times width times height. So 18 times 6 times 9, multiply those three numbers together, get 972 centimeters. And for volume, our units are always going to be cubed. So a 3 instead of a 2. And that's because we're taking 3 units and multiplying them together. So centimeters times centimeters times centimeters, right, which we think back to our power laws, something multiplied by itself 3 times is cubed. So the units would be centimeters cubed. For B, we're going to be looking at a cylinder. So a cylinder, right, let's go back to our formula sheet and let's scroll up to a cylinder, and we can see this one has a lot more formulas. So for surface area, it's telling us that we're basically finding the area of the base, and we're finding the lateral surface area, which is the outside portion or the portion around or the side of our cylinder. And then for the total, it's 2 times the area of the base, because we have a base at the top and at the bottom, 2 circles. And then the lateral surface, the surface around. And then it breaks it down even further to the specific formula, 2 pi r squared plus 2 pi r h. So again, all of this is just breaking down how we're getting our actual formula, but the one we're going to be using is the one at the bottom. Same thing for volume, it breaks it down to telling us what we're doing, base, area of the base times the height, or pi r squared times h. So again, lots of formulas in some cases, but go to the bottom of the section to look at what formula you should be using. Everything above is just breaking down how they come up with the actual formula. So our volume was 2 pi r squared, and then, or sorry, not our volume, our surface area. 2 pi r squared plus 2 pi r h. And then our volume is equal to pi r squared h. So r represents our radius. So in this case, our radius is equal to 8. We're not given the diameter, so we don't have to do any extra calculations. And our height is equal to 24. All I'm going to do now is just plug those values in and go through my calculations. So 2 times pi times 8 squared plus 2 times pi times 8 times 24. I'll do the volume one after. Keep in mind we have to do BEDMAS, so I have to do my exponents first. So 2 times pi times 8 squared, or 64, plus 2 times pi times 8 times 24. Now I have to multiply. I'm going to multiply each one separately and then add them together. Right? Or you could just probably type this all into your calculator at once. Remember, pi is 3.14, or use your pi button. You should get a surface area of 1,608.5 centimeters squared, because it's area. For volume, a little bit simpler, less of a calculation. So pi times r, which is 8 squared, times height, which is 24. I'm going to do my exponents first. So 8 squared is 64. And then I'm just going to multiply these three numbers together. Pi times 64 times 24. We get 4,825.5 centimeters cubed. So again, basic formulas, we're just plugging in values and just calculating. So we have to make sure we know how to do bed mass or just how to make sure we know how to use our calculators to enter everything correctly. Last one, a triangular prism or triangular base prism. So I'm going to go to my formula sheets and I'm going to scroll down to a triangular base prism. Right, there's a lot there, but I'm going to go to the very last one. Area of the total is base times length plus A times H plus B times H plus C times H. And for volume, base times length times height divided by 2. So those are going to be my two formulas. I'm going to come back and refer to this image because it's going to be helpful when I label all my different sides, because there's a lot of different variables that we have to look at. So we want to make sure we're labeling everything correctly. So I'm going to write out my formulas. So surface area was equal to base time or B times L plus A times H plus B times H plus C times H. And our volume was equal to base times length times height divided by 2. So if I go back to that diagram, it looks like L is going to be the height of our triangle. It looks like B is going to be the base of our triangle. H represents the height or the length or the side of the rectangles. And A and C are going to represent the two sides of our triangle. So if I go back and look at our shape, I've labeled it as such. We have our height, so our L is going to be 10.5. Our B is going to be 12. A and C are going to be 12. It's an equilateral triangle. Even though it doesn't mention it, we can assume, or I'm going to tell you that it is, so all sides are the same. And then H is equal to 26. So now that I have all this information, I can plug it into my formulas and calculate. So again, we want to make sure that we label everything correctly based off of our formula sheet, because it will be a lot easier to go through and do these calculations. Right, so B times L, we have 12 times 10.5 plus A times H, which is 12 times 26, plus B times H, which is 12 times 26, plus C times H, which is 12 times 26. I'm going to move the volume formula out and we'll put it down below. So again, I'm just going to go through, I'm going to calculate each one. Depending on how confident I am with my calculator, I could go through and enter this long string of multiplication and addition and get the same value or same answer. Although it's not too bad because 3 of the calculations are exactly the same. So these last 3 values are all 312. So 312 times 3, or 312 plus 312 plus 312, plus 126, we get a surface area of 1,062 centimeters squared. Volume's a little bit easier. Just multiplying 3 numbers and dividing by 2. So B times L. So 12 times 10.5 times 26, which is H, divided by 2. And we get 1,638 not cent, mistake, meters cubed. I'm using centimeters this entire time. So meters cubed. So just meters squared and meters cubed because we have different units. It's not centimeters anymore. So again, hopefully this is straightforward. A lot of it is just kind of plugging the values into the formula, making sure we have the correct values for each variable. So it really helps taking a look at these formula sheets, making sure we label all of our sides correctly based off of how it's labeled in our formula sheets. So making sure we know what each variable represents. And then we're just kind of plugging it in, following BEDMAS, and calculating.